Hello everyone, my name is Anushri, third year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation is data mining, its challenges and the tasks. By the subject Data Mining and Data Warehouse 21IS643. So first of all, what is data mining? Data mining is nothing but a process of extracting the knowledge from the data. Has it been increasingly important as the amount of data generated by the individual, organizations and the machines has grown exponentially. However, data mining is not without its challenges. In this article, we will explore some of the main challenges of the data mining. So first of all, the data mining is a process of extracting a knowledge or information from the data, and it has been growing. Has been growing enormously in today's world by the individuals, organizations, and the machines has grown exponentially. So the data mining has come up with some of the challenges of extracting the data from the information from the data. So those challenges are: first of all, we have the data quality. The data quality or the quality of the data used in the data mining is one of the most significant challenges. The accuracy, the completeness, and the consistency of the data affect the accuracy of the results obtained. So whatever we have, the accuracy of the result will be affected by the completeness of the data, irregularities and the noise in the data. And the data may contain errors, omissions, outliers or duplications or inconsistencies which may lead to inaccurate results. Moreover, the data may be incomplete, meaning that some attributes or the columns or the values are missing in the data, making it challenging to obtain a complete understanding of the data. So whenever we are working with the data may have some missing values, like some of the columns or the values may be null. So we need to optimize some of the techniques to handle these type of data. So the data quality issues can arise due to variety of reasons, including data entry errors, data storage issues, data integration problems and data transmission errors. To address these challenges, data mining practitioners must apply data cleaning and data pre-processing techniques to improve the quality of the data. So as I already said, we need to apply some of the optimizing techniques or data pre-processing techniques to the data to make it or to improve the quality of the data. Data cleaning involves detecting and correcting the errors, while data pre-processing involves transforming the data to make it suitable for data mining. Next of challenges we have is data complexity. Data complexity refers to the vast amount of data generated by the various sources such as sensors, social media, the Internet of Things. The complexity of the data may change or may make it challenging to process, analyze and understand the data. In addition to that, the data may also be in a different formats like JSON, CSV, PDFs or anything, making it challenging to integrate into a single dataset. To address this challenge, data mining practitioners use advanced techniques such as clustering, classification and association rule mining. These techniques help us to identify the patterns and the relationship between the data or between the attributes in the data, which can then be used to gain insights and make some predictions on the data. So next is data privacy and security. Data privacy and security is another major significant challenge in data mining. We all know that data security is the most important aspects of handling the data. As more amount of data is collected, stored and analyzed, the risk of data breaches and cyber attacks increases. The data may contain personal, sensitive or confidential information that must be protected. Moreover, data privacy regulations such as GDPR, CCPA and HIPAA impose strict rules on how data can be collected, used and shared. Most of us have credit cards, and some of the data of the credit card is very sensitive. When we are working with a data set involving a credit card, so we need some of the confidential information to be confident, and we need the data security and privacy so that the data breaches cannot occur. So to address this challenge, data mining practitioners must apply some data anonymization and data encryption techniques to protect the privacy and security of the data. Data anonymization involves removing personally identifiable information, that is PII, from the data, while data encryption involves using algorithms to encode the data to make it unreadable to unauthorized users. So next challenge is that scalability. So the data mining algorithm must be scalable to handle larger datasets efficiently. So once we are designing the algorithm, data mining algorithm, the algorithm must be applicable for both the smaller datasets or the larger datasets, and it must work the same way for the both of them efficiently. As the size of the dataset increases, the time and computational resources required to perform the data mining operations also increases. Moreover, the algorithm must be applied or must be able to handle the streaming data which is generated continuously and must be processed in real time. To address this challenge, data mining practitioners use distributed computing frameworks such as Hadoop and Spark. These frameworks distribute the data and processes them across multiple nodes, making it possible to process large datasets quickly and efficiently. Next is interpretability. Interpretability is nothing but how we can understand the data and how we can understand and work on the data. Data mining algorithms can produce complex models that are difficult to interpret or understand. This is because the algorithms use a combination of statistical and mathematical techniques to identify patterns and relationships in the data. Moreover, the models may not be intuitive, making it challenging to understand how the model arrived at a particular conclusion. So whenever we are building a data mining model or a machine learning model, we need to address this challenge to understand how the model can be arrived at a particular conclusion without any misunderstandings or any confusions. To address this challenge, data mining practitioners use visualization techniques to represent the data and models visually. Visualization makes it easier to understand the patterns and relationships in the data and to identify the most important variables. Visualization may also involve pie chart and bar graphs or line charts or anything to visualize the data and then identify the important attributes and the relationship between the features or the attributes in the column. So next is ethics. Data mining raises ethical concerns related to the collection, use and dissemination of the data. The data may be used to discriminate against certain groups, violate privacy rights, or to perpetuate existing biases. Moreover, data mining algorithms may not be transparent, making it challenging to detect biases or discrimination. We need to follow some of the ethics while developing data mining algorithms or techniques that must not raise any ethical concern. So next we have data mining tasks. Data mining tasks are broadly divided into descriptive tasks and predictive tasks. In the descriptive tasks we have clustering, association rule learning, summarization and anomaly detection. So first of all, what is clustering? Clustering is a type of unsupervised learning and grouping similar data points into the clusters. Example is customer segmentation to identify the groups with a similar buying behaviors. Next is association rule learning, discovering the interests, relationships and relations between the variables in a large databases. Example is market basket analysis to find the products that are frequently bought together. So whenever we are buying an item X, we are associated with buying an item Y also. If we are buying a bread, we are also associated to buy a milk with it. So that is association rule learning. Summarization. Summarization is nothing but providing a compact description of the dataset. Example, generating the summary statistics such as mean, median and standard deviation for the dataset is nothing but summarization. Anomaly detection. Anomaly detection is nothing but identifying the outliers or unusual data points. So as I already said, the data may contain some of the outliers, noises or some of the uncommon features, and those detection of those anomalies is called as anomaly detection. So example is detecting the fraudulent transaction in a set of a financial data. Credit card fraud detection comes under anomaly detection and under the descriptive tasks or data mining tasks. Next is predictive tasks. In predictive tasks, we have classification, regression and sequential pattern mining. In classification and regression comes under supervised learning. So classification is nothing but assigning the data points to predefined classes or the categories. Example is email classification into spam and not spam. Regression is predicting a continuous value based on input features. So example is forecasting the house prices based on the features like size, location and number of rooms. Sequential pattern mining is predicting the future based on sequences of the past events. Example is predicting the next purchase in online retail based on the past purchase history. This sequential pattern mining applies in e-commerce websites such as Amazon and Flipkart, wherever we get the suggestions for our next purchase based on our past purchases. So that's all for this video. Thank you.